it wasn't a real fair evaluation because, yeah, we were shooting at a trash can, not a real basketball, all that. All right, so here's what's going to happen. This is kind of an outline of what's going on. 9.1, which you're working on right now, is the basic idea, and we're going to learn all the little parts and pieces that go along to this test. We're testing the idea that some company makes. We're going to learn about a hoe, a hoe and a ha and a parameter, and a p-value is what we're going to talk about today, which is a probability. Why we can't use the word probability, I don't know. They shortened it to p-value for some reason. I know. 9.2 and 3, this one is going to be for proportions, you know, when you're using p and p hat. And then the next one, the last chapter, or section in this chapter, is about means when you're using these two things. So right now we're just kind of talking about the probability and the drawing the pictures, and it'll all come together at the end. All right, we should be right there on your notes, right? Am I right? Page 534? Okay. All right, let's read the problem. For the job satisfaction study described on the other page, this was the one where they had a machine paced and a self-paced. So you're in a factory and you are making something, whatever it is you're making, and there's like a conveyor belt and it's moving down the line. You have to put together your thing and it moves it on. And yesterday we said that if you could do that at your own pace, you probably liked your job better than if the machine is making you go at a certain pace, right? Now, the reason the ho and the ha were both 0 is because they're assuming that there is no difference, zero difference between the two satisfactions. We think there's probably a difference, right? But they're assuming that there is not. All right, mu is the mean difference in job satisfaction scores, self-paced minus machine-paced. And if they are both the same, then your difference would be 0. Data from the 18 workers. Okay, so we've got 18 workers here that took a test to see how satisfied they were with their jobs. The mean for the sample was 17. That means the people who did self-paced were 17 points above the others, which is what we thought would happen, right? And then it gives you the standard deviation. Okay. Now, researchers performed a significance test using the sample data and attained a p-value of this. Your p-value is a probability. That's like 23%. 23% chance that something would happen. In the previous chapter, I said we're not talking about probability. It's not a 95% chance on a confidence interval, right? Now we are. We're talking about probability. All right, explain what it means for the null hypothesis to be true. Y'all tell me which one of those is the null hypothesis. The top one, right? So what would it mean if this were true? It would mean that the people who did their job satisfaction test in the self-paced and in the machine-paced were exactly the same, because when we subtracted them, we got 0. All right, so here's all your information, and they gave you all of that in the problem. So y'all write that down. All of that was given to you, and it will always be given to you, unless we have to put something in our calculator, but that'll be later. Y'all write this down. When did I say we leave here? 11:05. 11:05. All right, the question says, explain what it means for the null hypothesis to be true. So if the null hypothesis, this one, is true, then it means this. This says that the average or mean difference in satisfaction scores is 0, meaning the workers don't favor one over the other. I doubt that. And as far as our sample is concerned, that didn't happen. But we are going to assume that there is no difference. This section is not all about the math. There's not a whole lot of actual math, which I guess y'all like. Might be why you're in the class, but it's a lot of just understanding what they're asking. And I think that's the hard part. You've got to really understand it. You can't just, you know, I was trying to think of an appropriate word. You can't just walk your way through it. Huh? All right, let's go back and think about what this means. The question was, what does it mean for the hoe to be true? This is what it means. It means that the workers don't favor one over the other because the difference between them was 0. So be thinking about what that actually means. All right, next question. Number 2, or part B, I'm sorry, not number 2. Interpret the p-value in context. Okay, this is my p-value. It is a percentage or a probability. So it's 23% or 23.02%. Everybody know where I got that? Move your decimal twice, right? Okay. I know that that's like 7th grade math, but still, I just want to make sure. So 23% of what? Well, here's what it means. The p-value. There is a 23.02% chance, because that's the number they gave us, of getting a sample of 17 points if the hoe is true. Other work. Oh, okay. This is just hard, so I want you to concentrate. When they give you the probability or the p-value, they're telling you there's a 23% chance of getting that sample. That's what they're saying. If there really is no difference between the workers' scores, then that sample has a 23% chance of happening that they gave us. The more we do this, the easier the terminology will get, but right now I know it's kind of hard. All right, last question, part C. Part C says, do the data provide convincing evidence against the null hypothesis? First of all, do the data still drives me crazy. I feel like it should say does the data, but I know data is plural. I get that, but it still drives me crazy. All right, do the data provide convincing evidence against the null hypothesis? All right, here's how you decide. We're going to look at this number and see if it's too big or too small. Well, it kind of 23 sounds small to me, right? Does it to y'all? I mean, like if I said you got a 23 on your test, what would you think? Okay, that's small. Now, weirdly, in the statistical world, 23% is gigantic. It's weird, I know. Small in the statistical world is like 3%, 4%, nothing over 5%. When you get into the 10%, they start thinking it's big. And that's strange to us, I know, because normally we think, okay, test scores, 23 is bad. But in the statistical world, 23 is very large. All right. So this is pretty often, 23%, to occur by chance. This is not convincing evidence against the hoe. It's kind of opposite of what you would normally think. Normally, you would think, okay, I got a test back and I got a 23 on it. Well, that kind of stinks. But in statistics world, 23 is large. They're saying 23% of the time this will happen. And that's pretty often to happen, to occur just by chance. Now, if it was a 3% of the time this would happen, then we could say, well, that's kind of weird. All right. Okay, so in a trial, when you watch Law & Order, or if you've ever been in a trial, anybody actually been in a courtroom? I have not. I've never even been on jury duty, which is weird. Strange. Knock on wood. I really don't want to be honest. I know, but then I'd be away from this, and I don't know. All right. So defendants have two options. They're either guilty or not guilty. No one ever says that they are innocent, right? On any murder trial, any other trial, you don't ever hear the people say, well, we the jury find the defendant innocent. It doesn't happen. They say, we the jury find the defendant guilty, or we the jury find the defendant not guilty. All right, now, we're going to do the same kind of thing. We're going to say we find evidence to reject or fail to reject. But we never use the word accept. Never ever say I'm going to accept it. You can say I reject it or I fail to reject it, which is kind of the same thing as accepting, isn't it? Right? All right. Now, here we go. So if our p-value is tiny, this was the free throw example where we had the proportion was claimed to be 80%, but we think the proportion of shots that they made with the free throws is less than 80. And in our example, it did come out less than 80, right? Right. All right. The p-value is 0.0075. That's like 0.75%. That's pretty tiny, right? Your p-value is small. Now, in this one, in the job satisfaction example, the mu was equal to 0. And we feel like probably the self-paced people would probably like it better. So your mean is not equal to 0. 23% is definitely bigger than that one, right? That's what you're going to start looking at. Look at your percentages. And we're about to use them to do something with it. Everybody got that written? All right. P-value small, you can reject HO. And we're going to conclude something, and I'll tell you in a minute. P-value large, you fail to reject the HO. Now, are you ready to learn how to remember this? P-value low, reject the HO. P-value low, reject the HO. That's how you can remember it. I wrote p-value small, but that doesn't rhyme. P-value low, reject the HO. P-value not low, don't reject it. All right. How do we know how low it is? Let me stop right here real quick. How low is low? What do y'all think? 1 is pretty low, 1%, 2%, 3%, 4%, 5%. Where is the cutoff is the question, right? 5.8. It's actually going to be about 5. There's something called an alpha level, and it tells us how low we can go, basically. All right, we can compare the p-value with a fixed value called significance level, and it's got this little thing. I don't draw it very well. It looks like the fish symbol, you know, like that. But when you type it, it looks a little bit like an O or an A, maybe. It's an alpha. It's a Greek letter alpha. It's like the lowercase Greek letter alpha. We use a lot of Greek letters in statistics. All right, so if your alpha is 0.05, that's 5%. That tells you your cutoff number. If your alpha is 0.01, that's 1%. That's your cutoff number. Most of the time it's 5. But they'll tell you in the problem what to use. All right. Statistically significant. If the p-value is smaller than the alpha, we say it's statistically significant. It's hard to say, statistically significant. And this is just a recap. If the p-value is less than the alpha, we reject the HO. P-value low, reject the HO. P-value greater than the alpha, we fail to reject. I wrote the words less than and greater than because some people don't remember those symbols. It happens quite often, actually. All right, now let's do an actual problem, and I hope it'll make a little bit more sense. So this is the problem I was talking about earlier. We have the Duracell Corporation. Hey, watch. Duracell Corporation. This company has developed a new deluxe AAA battery that's supposed to last longer than its regular AAA battery. Y'all don't necessarily care about how long your batteries last, I concerned about it. Like they really want their batteries to last super long. Okay. These new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Otherwise, they're going to make a whole lot of batteries and pay a whole lot of money for something that doesn't really matter. Based on years of experience, the company knows that its regular AAA batteries last for 30 hours on average. The company selects a simple random sample of 15 batteries and uses them continuously until they're completely drained. All right, so they gave you the ho and the ha. The original claim from the company is that the mean is equal to 30 hours. We're trying to figure out, is the mean greater than 30? That's the whole idea. Hey. All right, and mu is the true mean lifetime of the batteries. Here's your p-value. Thank you. All right, there's your p-value. We're going to decide what conclusion would you make for each of the following levels. All right. If the alpha is 0.05, we're going to say 5%, is that too big or too small based on our p-value? And I'll show you how you do that. Here you go. First of all, that's what the company told us. And that's what you did on your homework last night. So it should be getting easier and easier the more you do it. Do you see an X bar in this problem at all? No. Ho and ha's always have mu. Mu, not X bar. All right. Here's my p-value. They gave me that in the problem. We are going to write p-value and then a big circle and then an alpha. When you were in third grade, no, maybe second grade, because my daughter's doing it, and you were trying to figure out when the alligator mouth was opening up to the bigger problem, remember those? Yeah. That's what we're about to do. All right, what's my p-value? Did it tell me? Yep. Did y'all not use the alligator example? Really? Like, they didn't do points. Like, yeah, last night, or last week, Hannah was doing this. She had 13, and then she had a big circle, and then she had 15. And she had to determine which one was bigger. Well, clearly, right? And she would put greater than, and we said that the alligator mouth opens to the bigger number. Edgewood. All right. So my p-value, I know my p-value is 0.0267. You're going to write that right there. My alpha value, they just told me, was 0.05. 0.0267 compared with 0.05, who's bigger? Yeah, look at the first two numbers, 0.2, 0.5, right? 0.5 is bigger, right? Okay, remember the odd little sentence we said? P-value low, reject the ho. Is my p-value low? Reject the ho. When you reject the ho, it's called statistically significant.
Is that kind of like insight when like you want your whatever?
Yes. Yes, that's exactly what it is. I don't think that y'all go through why, which we're going to do, but yeah. All right, they told me my p-value, they told me my alpha. And then you just have to decide which one's bigger, and if it's p-value low, reject the ho, okay? All right, next one says my alpha is now 0.01. Is that going to change my answer? That's what we're trying to figure out. Yeah. Okay, once again, we're going to write your, oh wait, write this down below, sorry. We reject the ho. Y'all look up here. If I reject the ho, I'm rejecting that, which means I'm going with this one, right? The mean is greater than 30. Okay, that's what you're about to write. We reject the ho. So if we reject the ho, then there is enough evidence to conclude that the batteries are longer than 30. This is not mathematical at all. This is think through it in your brain, common problem solving. I have people every year that tell me they take this class because they didn't want to do the math. All right, we're going to do part B. Part B says my p-value stays the same, but my alpha was changing. Y'all remember what the alpha was changing to? 0.01. All right, so let's do it. Not that, sorry. All right, look, my p-value is the same as they gave me earlier, but my alpha is now 0.01. Does that change the direction of your alligator mouth? Yes. Concentrate. P-value low, reject the hoe. But guess what? A p-value is not low this time, is it? But we never say that word. You never accept the hoe. You never accept a hoe. In real life or statistics, either one. If you are rejecting the hoe, that's pretty significant because it's going to reject something that's common knowledge to begin with. But if you fail to reject it, it's not significant, not statistically significant. Let me go back up to the beginning. Well, go ahead and write that first, and then we're going to go back up to the beginning. All right, this time I am failing to reject the hoe. That's what the problem said, right? So let me take that off. I'm failing to reject the hoe, which means I'm rejecting this one, aren't I? Y'all see what I just did? I failed to reject the hoe, which means I'm rejecting this one. So is there enough evidence to say that they're bigger than 30? No, there is not enough evidence. And that's what you write for part B. We failed to reject the hoe. There is not enough evidence to conclude that the batteries last longer than 30. I want you to notice on part A and part B, when you talked about the batteries, it was always about the ha. Every time when you conclude, when you write this sentence, you are talking about the ha both times, not the ho. Both times we were talking about it lasting longer than 30. So it's either enough evidence to conclude that ha or not enough evidence to conclude that ha. Those are your two options. All right, I think we're going to stop right there. Yeah. All right, your homework. Over the weekend, you actually do have homework. Is 11 and 13, and you're going to be concluding based on the p-value, I think. Yes. Hey, everybody look at this real quick. Everybody look. This is called interpreting. Did I just spell that right? I don't know. Interpreting the p-value. It's going to ask you to interpret the p-value. Oh, I can't write. Sorry. That's it. That's how you interpret the p-value. So go back to your notes. Don't be like, oh my gosh, I have no idea how to do this. I'm not even going to try. Go back to your notes and look and see what you did. It's getting harder.